Hey there guys. In previous classes, we learned that mixtures are substances that contain two or more substances that have been physically combined together. A mixture may consist of a soluble solid such as salt in a liquid like water. It may also consist of an insoluble solid such as sand in a solvent like water. It could also be two different liquids like your yogurt and water. A mixture may also consist of two or more solids like chalk, sand, and salt. Now, these mixtures may be of two types. They could be heterogeneous mixtures or homogeneous mixtures. Now, what are homogeneous mixtures? They are those mixtures where the components have a uniform composition. That is, the components are indistinguishable from one another. They look like a single phase or medium, and we are often tempted to call them compounds. Several examples of these types of mixtures exist. They include a salt solution. Another example of a homogeneous mixture is a soft drink. On the surface view, a soft drink appears as though it contains just one substance. But on careful consideration, the constituents of these soft drinks can be detected. Our soft drinks contain water, carbon dioxide, sugar, colorants, acidulants like phosphoric acid, and even caffeine sometimes. Some other homogeneous mixtures are blood, air, and so many others. Now, blood is a mixture because it contains different substances such as our white blood cells that fight diseases, red blood cells that help transport oxygen around the body, platelets which helps with the clotting of our injuries, plasma cells which helps in the circulation of dissolved nutrients around the body. Now, air is already known to be a mixture of gases. It contains nitrogen gas, oxygen gas, carbon dioxide, moisture, dust particles, and even noble gases. However, on the surface, it seems to contain just a single substance. No wonder students say we breathe in oxygen and breathe out carbon dioxide. Truth is, we breathe in air, but our lungs select only oxygen and expels carbon dioxide. The carbon dioxide leaves the body alongside the other fractions of air that were not picked up by the lungs, and they go out through the nostrils. The other types of mixtures, heterogeneous mixtures. These are mixtures with a non-uniform composition. That is, the different constituents are clearly distinguished from one another. They do not form a single phase or medium. They cannot be mistaken for a compound because the layers that make them up are clearly different. Several examples of these types of mixtures exist. They include a mixture of palm oil and water. Sand is also a heterogeneous mixture, as it usually contains rocks, cement, stones, shells, and plenty other elements. Basically, in heterogeneous mixtures, the particles that make up the mixtures can clearly be seen to be contained in the mixture. Now, what are the differences we've learned between homogeneous and heterogeneous mixtures? 1. Homogeneous mixtures. The particles are uniformly distributed. While heterogeneous mixtures, the particles are not uniformly distributed. 2. Homogeneous mixtures, every part of the mixture has the same physical properties. While heterogeneous mixtures, every part of the mixture has different physical properties. 3. Homogeneous mixtures appear to be a single compound when viewed with the naked eye, while heterogeneous mixtures can clearly be seen to be composed of different substances. And lastly, the constituents of homogeneous mixtures cannot be separated easily, while the constituents of heterogeneous mixtures can be separated very easily using some filtration techniques that will be discussed in our next lessons. Cheers, guys.